Today we're going to introduce the topic of energy. And the first thing you need to do when you think about the topic of energy is get your brain around the equations for energy. I'm going to introduce 3 equations for energy today. Let's look at what they are and talk about their meaning. The first formula is for kinetic energy. The formula is K equals 1/2 mv squared. This is the energy of a moving object. So there's a mass and it's moving with a certain velocity and it has kinetic energy. So let's do a simple example about kinetic energy. Here's a man, he's got a ball and he's going to throw the ball. Let's give a mass. Let's say the ball has a mass of 2 kilograms. Let's say this guy throws this 2 kilogram ball at 11 meters per second. So this ball is going to fly. As it flies, it has kinetic energy associated with the motion. To calculate the kinetic energy, we plug those numbers in that formula. And we get, so those numbers give us 121. The units for energy is called joules. So normally we just write a big J. It comes from some French guy's name. Joule was his name. He was some scientist that did some stuff. So joules are named in honor of him. So this ball being thrown has a kinetic energy of 121 joules. So that's the idea of kinetic energy. Any mass, any object that has mass that's moving has kinetic energy. A car that's moving as a mass with moving has kinetic energy. A ball that's thrown has kinetic energy. If a car is sitting there and the velocity is 0, then it has no kinetic energy. So you need to have mass and velocity, and then you get kinetic energy. Okay, the second kind of energy is called potential gravitational energy. So the second kind of energy is potential gravitational energy. PE equals mgh. That's mass times g, 9.8 meters per second squared, acceleration due to gravity. mgh. H is height, a distance. So this is energy of when you're holding like a ball and it could fall. So it has the potential for gravity to give it energy. That's the idea. It's potential gravitational energy. So this ball is not currently moving if I'm holding it. Let me get an object. So here is like a pumpkin timer, some object. So I'm holding it here and it's high off the ground, about 1.5 meters. And so it has potential energy. If I let go of it, then it would not have potential energy more. That would turn into kinetic energy because it would be moving. But right now it's not moving, but it has height. So we say there is potential gravitational energy associated with me holding that object up there. So we can calculate that. Let's imagine there's a guy holding a ball. So he's holding a ball of mass 2 kilograms and it's a height of 4.5 meters above the ground. So those are the numbers. So he's just holding the ball over a cliff. It could fall. It's not yet falling. It could fall. So it right now has potential energy. To calculate the amount of potential energy, we plug the numbers into the equation, mgh. And I calculate this. I get 88.2 joules. So that ball that was being thrown had a little bit more energy at 121 joules. This has 88 joules. Kind of close-ish number, but a little bit less. So that's the energy of that ball. So a heavier object will have more potential energy, and an object that's higher will have more potential energy. It could fall. One way to think about potential energy is like when you're on a roller coaster and you're at the top and you feel that sense of anticipation that you're going to zoom down. then that is the feeling of potential energy that you're kind of about to go down. I'll just make a note. This thing gets some different names sometimes. Sometimes this is called PGE, potential gravitational energy, or GPE. And sometimes it's called U. I actually don't know why it's called U. Probably there's somebody that knows why. So PE, GPE, PGE, and U, these are all the same idea. It's object with mass that could fall, but it's not yet falling. Potential gravitational energy. So the first kind of energy is called kinetic energy. The energy is something moving. The second type is potential gravitational energy. The third kind of energy is the energy associated with a spring. So this is ES, energy of a spring, is 1/2 K delta X squared. So the energy of a spring is 1/2 Kx squared. K is called the spring constant. It's a number that has to do with how strong a spring is. A higher K means it's a strong spring and difficult to compress. Delta X is the change, the distance of compression that spring has undergone. Let's do an example of this. So here's a spring, and I gave it K, spring constant is 200 newtons per meter. There's some box on here, and somebody comes and pushes on that box. And they compress the spring backwards. Let's say they can compress it 15 centimeters. So delta X will be 15 centimeters. I need to write that in meters, so 0.15 meters. So to calculate the spring energy, I'm going to put these numbers into that formula. 2.25 joules. So that is quite a bit less than the amount of energy that was in the first two examples. Just 2 joules, 2 and a bit joules. So one comment or two comments about the spring energy. This is also a potential energy. This is the energy kind of pent up in the spring after you've compressed it. You compress that thing there, and there's some energy inside that spring. And if you let it go, it's going to shoot the block out or just shoot the top of the spring forwards. And that's going to expel the energy in some other fashion. So here are 3 basic types of energy: kinetic energy, potential energy, and spring energy. There's actually many kinds of energy in the world, and we only cover a certain number of those kinds of energy. But we need to understand these 3 formulas and be able to put basic numbers in them, and also be able to move the variables around. If you want practice using these formulas, I have some worksheets on my website so you could spend time getting comfortable using these formulas and plugging numbers into these formulas.